Okay, guys, mic check. Welcome back to another episode of How to LeetCode with Jeff. I forgot what episode number we are on. It has been a while, just dealing with some stuff. But yeah, let's. Today we're gonna be solving LeetCode 142 linked list cycle, the second iteration of the problem. So what's cool about this problem is that it's one of those where like you basically know the algorithm or you don't, and we touched on it in a couple of the other linked list problems. Like for example, the last iteration of this problem was using the same algorithm, but it was tagged as easy because there's just like one step. So you just detect if there's a cycle. We're gonna be using a little bit of that logic with the slow and fast pointers, aka the tortoise and the hare situation, where you shift the slow pointer by one, shift the fast pointer by two, and if they meet, then we can detect that if there's a cycle. And to preface this, there is a little bit of there's some caveats like note that the position is not passed as a parameter. We don't want to modify the linked list, and there are a couple ways to solve it. We'll go over two. Um, One that uses the follow up, which is O of one, so constant memory versus O of n memory with the set approach. So yeah, we can start going over the set approach first because the code is relatively trivial. So yeah, let's jump right into it. I don't think this one needs a drawing example. Um, yeah, so we're gonna be utilizing a, let's just call it a hash set. But you can call it whatever you want. So we initialize our hash set, which is used to keep track of visited nodes within uh, within the list that we've seen before. And ideally, so we know that it's zero index, and we're gonna be returning the node where the cycle begins. And if there is no cycle, return nothing. So what we can do is have our current pointer to initialize at the start of the list and start traversing. We want to say our condition is going to be if our current is in our hash set already. So if we've seen this before, essentially, that's not the right syntax. If it's in the hash set, then we want to automatically return the current pointer as we've seen it before, and that means that that is going to be the start of our linked list cycle. Otherwise, we want to, if we haven't visited the node before, uh, we're going to add this to our hash set. So hash set, I believe it's dot add the current pointer, iterate our next pointer, and return we can return none here. So this solution should work. Yep. But it's asking us basically, can we do better? Which we definitely can because it's telling us we can. Follow up. So we don't want to use the hash set anymore, right? Let's see how we can do this. Um, yeah, so I'm gonna assume that you guys know how to detect it. Detect the cycle first so I can show you guys. We'll initialize a slow and a fast pointer. This is the beginning of the second approach. Slow and the fast pointer are both going to be initialized to the head of the beginning of the linked list first. So after they meet, the slow pointer is going to be in the middle of the list, and the fast pointer is going to be at the at the end of the list, I believe. Um, if there wasn't a cycle, um, that might not have been the best explanation, but bear with me. While fast and fast on next still, while there is still a valid node. So while there still is a valid node, we want to keep track of where the fast pointer is. And our intuition here is once we know that they're in the perfect place, we can actually set the slow pointer back to the beginning and keep track of where that fast pointer was. So we'll call it a different variable, and we'll have it. There's like a mathematical explanation as to why this works, but all we need to know is that as they march towards each other, not this way like together, but as they meet. So let's say 3 is going to be here, -4 is going to be here. The amount of times that they march is going to be where the linked list cycle starts. So we can go ahead and increment our slow pointer by 1 and increment our fast pointer by 2. And if they're equal to each other, we'll break out of this loop. And we're gonna deal with an edge case here where what happens if there was no cycle, so meaning that the fast pointer reached to null. So we're gonna go ahead and say if not fast and or not and, if not fast or not fast not next, we also want to return as there is no cycle, right? Now we can go ahead and set our slow pointer originally to the head, and we can set our, let's call it slow2, equal to where the fast pointer ended up landing, and we can go ahead and march them together. So while slow, if slow is equal to slow2, we want to go ahead and return we're returning the actual node, not the actual value. So now we can increment else, we can increment our pointers. Slow is equal to slow dot next, and slow2 would be equal to slow dot next, and we just return here, and this should also work. That is not a good sign. I might have missed something. Time limit exceeded. Slow, fast, head. If slow is equal to slow2. Oh, I see it. This is supposed to be slow2. Yeah. Well, you don't want to increment that one by 2. So there we go, guys. This is how you solve linked list cycle 2. I will probably put a more in-depth explanation maybe in the description or some of the techniques that we use, but keep in mind that step 1 for the O of 1 approach, we're going to be using slow and fast pointers. Step 2 is going to be keeping track of the fast pointer and incrementing it by 1, and also incrementing the other slow pointer by 1 after we have set it to, so after we set it to the start of the list. And yeah, that is gonna be linked list cycle. I'll see you guys in the next one. Probably expect a couple videos, new videos. And yeah, have a great day, guys.